We now discuss the solution of a problem from the section Permutations and Combinations. The problem is related to the distribution of certain number of objects into certain number of groups with a given constraint. This question has appeared in the joint entrance examination main held on 6th April 2023 in the first shift. The given question is the number of ways of giving 20 distinct oranges to 3 children such that each child gets at least one orange is. We are given 20 distinct oranges and it is to be distributed to 3 children such that each child gets at least one orange. In how many ways this distribution can be done? That's the question. We now discuss the solution of the problem in detail. We recall a result from the section Permutations and Combinations. The number of ways of distributing n distinct things into r different groups if empty groups are not allowed is. So it gives the number of ways of distributing n distinct things, means different things, into r different groups subject to the constraint if empty groups are not allowed. That means each group must get at least one thing or one object. Then the number of ways of distributing is given by r power n minus rc1 into r minus 1 to the power of n plus rc2 into r minus 2 to the power of n minus etc. plus at the end we will get minus 1 to the power of r minus 1 into rcr minus 1 into 1. Right. Let's now apply to our question. The number of ways of giving n is equal to 20 distinct oranges to r is equal to 3 children such that each child gets at least one orange is. Each child gets at least one orange is same as empty groups are not allowed. That means every child must get at least one object. Then we apply that here. You will get r power n, that is 3 power 20 minus 3c1 into 3 minus 1 to the power of 20 plus 3c2 into 3 minus 2 to the power of 20, and it stops because 3 minus 2 is 1. Agreed. So when you simplify, 3 power 20 minus 3 into 2 power 20 plus 3 into 1 power 20. When you simplify, you will get these big numbers. When you add, you will get this big number. This is 3,483,638,676. That is your answer according to the question when you have these distinct oranges. Right? When you have this distinct oranges. So that's the question, that is the answer, and that's the detailed discussion of that question. But I was told by some of our teachers that the answer is 171, sir. It is not this big number. But when I check it up with key, the key says this is your answer. But our question is how this 171 should come. For that, we have to change this question. So how do we change? This distinct word is changed, and we present that question in the next slide. Right. Now this is a changed question. This is not the same question given in the examination. The number of ways of giving 20 identical oranges, indistinguishable oranges, to 3 children such that each child gets at least 1 orange is. So, if I change the question to this, that is as identical oranges, indistinguishable oranges, then the number of ways will change. So, for this question, let's have a solution here. We recall the number of ways of distributing n identical things into r different groups. If empty groups are not allowed, that means every group must get at least one thing, that is one object, that is given by n minus 1 CR minus 1. So apply now here. So in our case, the number of ways of giving n is equal to 20 identical oranges to r is equal to 3 children such that each child gets at least 1 orange is. So each child gets at least 1 orange is the constraint. That constraint is same as empty groups are not allowed. It is same as that one in that. So then that will be equal to 20 minus 1 C3 minus 1, that is 19 C2. That when you simplify, 19 C2 is 19 into 18 by 1 into 2. That is same as 19 into 9. When multiplied, you will get 171. That's our answer. But this is the answer to this question, where this 20 different oranges were given in the given question. For that is the answer. And if you change that 20 different oranges to 20 identical oranges, indistinguishable oranges, if you change it, then the answer is 171. But for the given question, that was the answer. That's it. That's it. But if you change the question like this, you will get the 171. I am sure you have understood this solution of this problem, and I hope that it is very clear to you. And I am sure that you have understood both the problems and their solutions, and I wish you all the best. Thank you.